All right, welcome to Pre-Cal 12. We are looking at chapter 4 today, and the whole unit is about transformation of the graphs, okay, transformation of the functions. Today we're going to be looking at translating graphs of functions. So recall in Pre-Cal 11, we did a little bit of it. We actually did translation and expansion, actually, expansion and compression of the quadratic functions. So we are going to apply the idea to other kinds of functions, okay? So here is the quadratic function that we've seen in Pre-Cal 11, y equals x squared. How is this graph related to this, x squared plus 3 and x squared minus 3? So hopefully you remember this. If we have a plus 3 after x squared, what happened was, okay, let me just do a quick review. This is the graph for the parabola, right? This is the graph for the quadratic function, the parabola. If it's x squared plus 3 at the end, it actually just means that the parabola, it will remain the same shape, same size, but it's just going to move up by 3. So here, this is going to be at 3 now, okay? Whereas if it was x squared minus 3, then this graph is going to be, again, same shape, same size, but now the graph has a vertex at negative 3. Okay, so there is the second graph. Okay, so how are they related? Really, the plus 3 and the minus 3, these two talks about vertical translation. Okay, so it's either move up or move down, depending on whether it's plus 3 or minus 3, or whatever the number is. Okay. How about the second one here? So similarly, we are going to compare y equal to x squared with x minus 3 squared. Okay, so this time, the difference between this and the x minus 3 squared is that we are going to take the x and then minus 3 or plus 3, not after the x squared. Okay, not after the entire function, right? If we compare with this plus 3 really is added to this entire function. This minus 3 is subtracted from that entire function. Whereas the second example, we are looking at taking away 3 from the x. Okay, it's not from the entire function, but from the x. And this is add 3 to x. So again, this is simply a parabola that looks like this. If you recall, this is, again, same size, same shape, but this case, if you think about it, the first two, these two are vertical translation. I don't think it's too difficult to guess. This is going to be horizontal translation. The question is it going to move to the right or left? So be careful. I know you see x minus 3, so you might think, okay, I'm probably going to move to the left. In fact, it's the opposite, okay? If you see x minus 3, it's actually going to move to the right. So like this. And now this x value is going to be 3. Whereas this one, this is going to move to the left by 3 units. And this x value here is negative 3. Okay, so now this is this and that, of course. These two are horizontal translation. Now, how do you remember if it's going to be horizontal or vertical translation? You can think about horizontal translation. That one you can easily tell because it is with x, right? Horizontal is about x-axis. So horizontal, you see the change is about the x. That it goes from x to x minus 3 to x plus 3. So we're changing the x, therefore it's horizontal translation. Makes sense. This is a vertical translation because we're adding or subtracting after the function, right? So you got a y value, and then what you're going to do is you're going to add 3 to that y value, and therefore you're changing the y values now. That's why it's a vertical translation. Okay, so that's a quick review from Pre-Cal 11. Here's a think question. Well, these results hold true for other types of functions. Of course, yes. Okay, yes. These results will be true for other types of functions, and we will actually look at other types of functions more extensively later on. Not this chapter, but later on. This chapter is just about how the translation is going to work. Okay, so now let's look at the I don't know why it says example 2. This should be example 1. Sketch the image graph. So image graph means the graph that's being translated or moved or transformed. It doesn't have to be translated, it could be expanded or compressed. Okay, sketch the image graph after each translation. Write the equation of the image graph in terms of the function f, and then state the domain and range of each of the image graph. Okay, so here, let me just write down the points. Okay, so this is, I'm not gonna write there. So this is A, and that's -3, -1. We have B, which is -1, 2. C, which is 4, 0. D, which is 5, -2. So these are the 4 points, and this function, this graph, is f of x. So now we're gonna do part A first. It says a translation of 2 units left. Okay. Actually, I'll figure out domain and range here for the original function first. The domain and range, recall, domain is about the possible x values. So what are the possible x values for this function? Well, if I look at this graph, I know that my possible x values goes from -3, right? Here is my leftmost point. So this goes from -3 to the rightmost point right here, which has x value of 5. So the domain is going to be from -3 to +5. Whereas range will be the possible values of y. So it goes from the lowest point, which is still this point right there, D. It goes from -2 all the way to the highest point, which is +2, which is at B. Okay, that's the highest point. Okay, so that's the domain and range for the original function. Okay, now let's work on part A. I'm going to use blue for part A. Okay, so blue. We're going to move 2 units left. Okay, so now if we are going to move 2 units left, I'm going to call this A prime. Okay, so my new A coordinates of A, new coordinates of B, new coordinates of C and D. So if I'm moving 2 units left, obviously then I'm changing the x value, and because I'm moving left, so what I need to do is really take away 2 from x. Okay, so it goes from -3 to now -5. Goes from -1 to now -3. Again, you see how I'm just subtracting 2 to the original x value. 4 minus 2 is a 2. 5 minus 2 is 3. Because we didn't do any vertical translation, so all the y values will remain the same. So we will still have -1, 2, 0, and -2. So these are my new points. Okay. So now I'm going to plot them. -5 and -1 is right here. -3 and +2 is here. 2, 0 is here. 3 and -2 is here. And now I can join them together. You might ask me, why do I need to go through this step, writing out the coordinates? Why not just take these 4 points and then move to left? Obviously you could. Mind you though, because we are doing something simple right now, so that's definitely doable. However, later on we are going to do more complicated steps, right? The question is going to involve more complicated steps, and therefore I think it's useful to do a step-by-step at this point, okay? And we'll maybe later on you can skip steps, that's fine, but I think for now we should just stick to it. All right, what about the domain range of this new graph now? Well, because we are moving left, therefore we're not changing y value, so the range actually remains the same. It goes from -2 to +2. However, domain is going to change because we move everything to the left by 2, so it goes from -3. Well, now it's going from -5, and it ended at 5, but now it's only going to end at 3 now. Okay. All right. So now we are going to do B. And I'll do this in green. So now we're going to move 3 units up. Okay, so again, taking from the original coordinates, I guess I'll call this double primes. So A double prime, B double prime, C double prime, and D double prime. Because now I'm moving 3 units up, I'm not really moving sideways. Therefore, the x values will remain the same. So -3, -1, 4, and 5. For the y values, because I'm moving up, so I need to add 3 to it. Okay, so from -1 plus 3, that's a 2. 2 plus 3 is a 5. 0 plus 3 is a 3. And -2 plus 3 is a 1. So now I can plot. -3 and 2 is, oops, -3 and 2 is here. -1 and 5. And then 4, 4 and 3. Finally 5 and 1. So there is my graph for part B. Okay, you notice how the shape remains the same. It's just that we are shifting the graph sideways or up and down. Okay, in this case, domain is not going to change because we are moving the graph up and down, not sideways. And because we're moving up by 3, so all the y values will increase by 3. So it was, the minimum was -2, so now it's going to be at 1 because we add 3 there. The maximum was a 2, now it's going to be a 5. All right, the last step the last thing that I haven't answered is this. It says write the equation of the image graph in terms of the function f. Okay, so the red or the original graph, this has a function f of x. Blue is no longer f of x. Okay, it's going to be moving sideways, right? It says moving 2 units left. So I should say y equals f of x here. Now part B, this is no longer y equals f of x. Okay, we are moving 2 units left. If you look from the example here, which one is moving left? Is it x minus 3 here or x plus 3 there? Well, notice moving left is actually the x plus 3. So same thing, this is going to be y equals f of x plus 2. Notice how I'm replacing x with x plus 2. Okay, because first of all, it's horizontal movement. Okay, therefore I need to change x. And because it's moving 2 units left, I'm replacing x with x plus 2. Okay, if I'm moving right, let's say moving 3 units to the right, then instead of f of x plus 2, it's going to be f of x minus 2. Or I should say 2 units right. Okay, then it will be f of x minus 2. Okay, so be careful. That's one part that students often get tricked on. Okay. Whereas for the vertical shift, okay, vertical translation, we are moving 3 units up. So this one is actually quite clear. This is simply adding 3 to the function at the end. So I'm not changing anything with x, so it remains f of x. But because we're moving up by 3, so I need to add 3 to the function, okay, to the original function. And there is my the function for the image graph. Okay, so before you move on to the, you know what, just move on. Okay, so here we go. I'll do a quick summary at the end. Okay, so here is the practice question for you to do. Okay, so I have 5 points labeled for you. You need to do this. Okay, this is a combination of 2. Okay, not you don't need to do it twice. This is just one question. Okay, you're doing translation of 2 units right. 2 units down and 3 units right. Okay, so pause the video. And if you had questions, you might go back and rewatch it again. I don't know. Okay, or if you're fine, pause the video and try this question. Okay, so I'm assuming you're finished. I'm just gonna label the points. I always label from left to right. So I have negative 0.653, comma 0 to negative 2.879, comma 0. Oh man, okay, never mind, that's not left to right. This is the first one, negative 2.879, comma 0, and then negative 2.3 is my next point. And then it's gonna be negative 0.653, comma 0, and 0, comma negative 1, finally 0.532, comma 0. Okay, so these are my 5 points. We are going to change now. Okay, so it becomes. Okay, we are moving 2 units down and 3 units right. Notice this is the x coordinate and y coordinate, right? So I'm gonna deal with the x first. It says 3 units right, so all I need to do is plus 3. Okay, so negative 2.879 plus 3. Okay, I believe this is 0.121. 0.121. Yes, okay. Negative 2 plus 3 is 1. Negative 0.653 plus 3, this should be 2.347. 0 plus 3, that's easy. And 0.532 plus 3 is just 3.532. Okay, now for the y values, I'm moving 2 units down. So what I need to do is take away 2 from the original y values. it was 0, minus 2 is now negative 2, 3 minus 2 is a 1, 0 minus 2 is negative 2, negative 1 minus 2 is negative 3, and 0 minus 2 is negative 2. So now I have all my new 5 points ready. Oh, I shouldn't use red, hey? The graph is already in red. I'm going to use blue, okay? So I'm going to plot these 5 points on the grid. 0.121 is somewhere here, and negative 2, so here. 1 is here. 2.347 and negative 2, 2.347 somewhere here, negative 2 here. 3, negative 3 is here, that's my minimum. 3.532 is here, and negative 2, so here. So the graph looks something like this. So the shape will not change. Notice how the shape is not going to change, okay? So really we just need to join them now. And something like that. Here is my answer. Okay, so now I need to state the domain and range. Now looking at the original function, what's the domain and range there? Okay, well, this graph keeps going forever to the left and down. This graph, or this side of the graph, keeps going up and to the right forever. Therefore, the domain and range here would be all real numbers, and therefore the domain and range will also be all real numbers, okay? Because, I mean, moving to the right or left, or moving up and down does not really change the domain and range for the all real numbers, because it's still all real numbers, okay? So that doesn't change. Okay, now the original function has the equation y equals f of x. Now what about the new function? Well, the new function is no longer going to be f of x because we are moving 3 units right. So this time, instead of x, we are going to so this means replace x with x minus 3, okay? Because we're moving 3 units right. And because moving 2 units down, this means subtract 2 at the end of the function. Okay, so it was just f of x. Now because it's moving 2 units down, so I need to minus 2 at the end. So this is my function for the image graph right there. Okay, hopefully that was clear. Yeah. Okay, we will move on. Explicit equation. So this explicit equation really is something that we've done in the past. It's just basically it's written. In calculus, we will be dealing with something called implicit equation that you probably haven't seen. But if it's explicit, this is all the equation we've seen before. Okay, it's written in the form y equals f of x. In the form of y equals f of x. Of course, it doesn't have to be y, it could be g, and it doesn't have to be f of x, it could be g of x, h of x. Really, they are just names, okay? So this is explicit equation, okay? Now, f of x could be any function, right? Could be any function. Could be linear function, quadratic functions, or trig functions, any other functions. And here's the example right here, okay? Example 2. This is the actual example 2. You see, this is a function, 1 over x. Okay, this is a rational function. It says the graph of y equals 1 over x is translated 3 units left and 2 units up. What is the equation of the image graph? So this is the original function. Now it has been translated 3 units left and 2 units up. We are looking for the image graph. Okay, we are looking for the equation of the image graph. So now what we need to do is replace. Okay, so first, this 3 units left means replace. Okay, it's left, so it's sideways. Therefore, we're replacing x. Replace x with, and because it's 3 units left, so we're going to replace x with x plus 3. This is 2 units up, which means we're going to add 2 to the end. Okay, so now here's the answer. It's actually very easy. Okay, y equals 1 over x. So it says replace x with x plus 3. So here I see x, I am going to write x plus 3 instead. Now it says we're going to add 2 to the end. So be careful. To the end doesn't mean here. Okay, to the end means at the end of the function. So after 1 over x, that's finished. So we're going to add 2 to that. So plus 2 at the end like that. So this would be the image graph. Okay, that would be the equation of the image graph. All right, hopefully that was okay for you. Here is the practice question for you to try. Good luck. Okay, so here we go, 2 units right. This means replace x with x minus 2. This means plus 5 at the end. So your equation would be y equals, again, now I see x. Okay, sometimes there is more than one x, right? Remember, the equation could be x squared minus 2x plus 1, something like that. You are replacing every single x, okay? Every single x, not just the first one you see, okay? The example I gave you here are just one x each, but then again, there could be multiple x's. You have to replace every single one of them. Okay, so this is gonna turn out to be, okay, so instead of x, it's gonna be x minus 2 now, and then squared. Minus 1 is still there. Now because this is moving 5 units up, again, we're going to add 5 to the end of the function. So after x squared minus 1, which is what we have here, we're going to add 5 there. Okay, so if you simplify this actually becomes x minus 2 squared plus 4. And there is your image graph, or the equation of the image graph. Okay, it could be tricky, so be careful. All right, example 3. It says describe how the graph of 1 over x, so that was the function I showed you earlier, and that's what it looks like, could have been translated to create the graph of each function below. What are the equation of the asymptotes of each image graph? Okay, so if you look at this function, I should type in really y equals 1 over x. How does that compare with this? Well, really the only difference here is that x has been replaced with or by x minus 3. So this means we are translating. All right, okay, I'm gonna write this. It's a horizontal translation, horizontal translation of 3 units to the right. Okay, so from now on, I'll just write HT, stand for horizontal translation 3. Okay, so that's simplified a little bit. Okay, horizontal translation 3. If it's 3 units left, then you'll be -3 and so on. Okay, so this is what happened. It's horizontal translation of 3 units to the right. So we finished the first question. Now the second question says, what are the equations of the asymptotes? Okay, so asymptotes, if you have not heard that phrase or that word before, asymptotes, there are for now, two kinds of asymptotes that we see here. There is the vertical asymptote and there's the horizontal asymptote. So an asymptote is an imaginary line that the graph goes towards, but it will never touch. That's a loosely definition for now. Okay, it's not completely true, and I'll show you what's not true about that later on in the year. But for now, asymptotes are basically imaginary lines that the graph will go towards but will not touch. Okay, so we actually have vertical asymptote right here. You can see the graph is going towards the asymptote, towards this dashed line that I drew here, but it does not actually cross or touch. Okay, you can see it's going that way. That's a vertical asymptote right there, and it has an equation of x equals 0. We have another asymptote, and this time is a horizontal asymptote, and it is right here. You can see the graph goes towards the horizontal line right there, but it will not touch, and this equation is y equals 0. Okay, so here we go. If we have horizontal translation 3 units to the right, do you think that it's going to affect the vertical asymptote or the horizontal asymptote? Well, because we're moving sideways, this horizontal asymptote, if you're moving sideways, I mean, it's still there, right? You're still moving that line sideways. Whereas the vertical asymptote, if you move it sideways, well then, yeah, it was at 0, but because the horizontal translation of 3, the new vertical asymptote is not going to be here, right? Because we're going to move 3 units to the right. Okay, so now the equation of the asymptote, okay, so asymptote, the equation is now going to be x equals to 3. Okay, this is the vertical asymptote. Okay, so from now on, I'll just call this VA, okay, vertical asymptote. The horizontal asymptote does not change though, okay? HA, this remains the same, y equals 0. Okay, what about the second one, part B there? Okay, so this is a little bit tricky because okay, 1 over x plus 2, that's not a problem. I think we know how to deal with that. But this time it's y plus 2. Well, this doesn't really look like what we've done before because it's always at the end of the equation, right? This time it's not, but that's easy. We can just simply move this plus 2 to the right. So then this becomes y equals 1 over x plus 2 minus 2. Okay, so now we can work off from this. We have a horizontal translation because x is being replaced by x plus 2, so this is 2 units left, so ht negative 2. We have vertical translation, we have a minus 2 here, so same thing, we're moving down by 2. Okay, moving down by 2. So now our new vertical asymptote, VA, this is going to change again because horizontal translation of negative 2, we're moving 2 units left. So the equation is now going to be x equals negative 2. Horizontal asymptote, this was the horizontal asymptote right here. Because we're moving down by 2, so the new horizontal asymptote is going to move down this way to here. So then the equation is going to be, sorry, not x, y equals negative 2. Okay, so that would be the equation. Okay, hopefully this was okay for you. There's the practice question. Good luck. Okay, so let's see how you do. We need to move the 3 over, and this becomes plus 3. So this is a vertical translation, 3 units up. Okay, and we have 2 asymptotes here. Again, one is at x equal to 0, the other one is at y equal to 0. Because we have vertical translation, so the vertical asymptote does not change. So our vertical asymptote still has an equation of x equal to 0. However, horizontal asymptote will not be the same. It's not going to be y equal to 0 anymore because we have moved the graph 3 units up. So this is now going to be y equals to 3 now. Okay. All right. For part B, same thing. I need to move the 4 over first. Minus 4. So now this is a vertical translation of 4 units down, horizontal translation of 3 units left. Both my vertical asymptote and horizontal asymptotes are going to be different now. VA, vertical asymptote is going to be affected by the horizontal translation because the vertical line. So we move 3 units left. So now this is going to have an equation of x equals negative 3. Horizontal asymptote, this is affected by the vertical translation because we're moving 4 units down. It was at y equal to 0, so now it's going to be at y equals negative 4. Okay, so be careful. Vertical asymptote is affected by the horizontal translation, whereas the horizontal asymptote is affected by the vertical translation. It's kind of confusing because it's the other way around, right? It's the opposite. All right, last example for this lesson today. The point 1, negative 2 lies on the graph of y equals f of x. State the coordinates of the image of this point under the following transformation. So this was on this graph. What happened to this point under this transformation? Okay, so let's take a look. Well, again, first step, I should move the negative 2 to the right. So this becomes f of x plus 2. This means vertical translation by 2. That means 1, negative 2 will become 1, 0 because I just need to add 2 to the y value. Okay, hopefully that makes sense to you. This is written in the form that we like already, so that's perfect. This is a horizontal translation of 3 units left and a vertical translation of 5 units down. Therefore, 1, negative 2. So what we need to do is minus 3 for the x value. So 1 minus 3 is negative 2. And minus 5 for the y value. So negative 5 minus 5 is negative 7. And there are my answers. There's no practice question for you for this one here, but hopefully that makes sense though, okay? So let's do a quick summary here. Okay, so this is what we're looking at here. We are comparing this with the original function y equals f of x. Okay, we have y equals f of x minus c plus d. Okay, so if c is greater than 0, be careful. When c is greater than 0, it actually looks like this. Okay, it actually looks like f of x minus 1, right? That actually means when c is bigger than 0. And now that makes more sense why x minus 1 is actually moving to the right, because c is bigger than 0. Okay, x minus 1 means actually c is bigger than 0. So when c is bigger than 0, we have a horizontal translation to the right by c units, okay, whatever the value of c is. The other way around, if c is less than 0, then we would have a horizontal translation to the left by c units. Okay, because when c is less than 0, it actually means x plus 1. Okay, let me just show you one more time, because if less than c is -1, then we have x minus -1. This actually you can see there's two minuses, so it actually means x plus 1, right? So when c is less than 0, it actually turns out to be f of x plus something. So that's moving to the left. Okay. If d is greater than 0, well, if d is bigger than 0, that simply means f of x plus 1, something like that, right? So this means we have a vertical translation up, I guess. Sorry, it was a long pause. We have vertical translation up by d units. Okay, and if d is less than 0, that means f of x minus 1, something like this. We have a vertical translation down by d units. Okay, so that really is the summary for today's lesson. There's a last question for you to think about. Is there a situation where horizontal translation can be considered as a vertical translation? The answer is yes, and I'll let you think about, I'll let you try to come up with an example, I suppose, okay? But the answer is yes. And it doesn't happen very often. I think it only happens in a linear situation. I'll give you the example, fine. Let's say this. If you just compare this, if you compare these two, you would think, okay, so this is a horizontal translation 2 units to the right. But if you write it this way, this is actually a vertical translation of 2 units down, right? This is horizontal translation, but this is vertical translation. But you can tell, I mean, they are just the same function, right? Y equals x minus 2. Because you read it differently, you actually think differently, right? One is a horizontal translation, one is a vertical translation, and they actually are the same thing. All right, that's it for today. Let me know if you need help, okay? Otherwise, good luck with your practice questions.